Hilchos Kidush haChodesh LaRambam, Chapter 17, The Calculations of Keshes HaRe'iyah, the Arc of Sighting. In this chapter, the Rambam concludes his calculations to know when the moon will be visible after the Moilad. When does the moon become visible? There are two factors required. A, the crescent of the moon must be large enough to be seen on Earth, and B, that it become sufficiently dark for that crescent to be seen. These two factors are dependent on the angular distance between the moon and the sun, and between the moon and the horizon. These distances are the topic of Chapter 17. Halachas Aleph and Beis. Find the angular distance between the moon and the sun according to their respective mokim amiti, their accurate position. This distance is called Eirach Rishon. It is the first of a series of longitudinal positions to be measured. From the Eirach Rishon, we can already know how large of a crescent the moon will have, and if there is even a possibility to sight the new moon. Next, find the Roichav, the moon's latitude position. We will need it later on. To understand halachas Gimel and Daled, when the moon is found between the mazoles Gdi and Toimim, it has a northerly orientation. These mazoles are called mazoles oilim, ascending mazoles. By contrast, when the moon is found between Sartan and Keshes, it has a southerly orientation. These are called mazoles yordim. For example, the sun set, and there is a 15-degree difference between the moon and the sun. The Galgal Hayoimi advances the moon toward its setting in the western horizon. However, because of its own movement in its Galgal, during this hour, the moon will be moving slightly eastward, delaying its approach to the horizon, so it will set later. In addition, when the moon is found in the ascending mazoles, it will also move northward, and its setting will be even later. When, by contrast, the moon is found in the descending mazoles, even though its movement in its own galgal will cause it to move away from the horizon, nevertheless, since it has a southerly orientation, it is moving to where the setting is earlier. On this basis, we can understand halachas Gimel and Daled. In halacha Gimel, the Rambam states, when the moon is found between the mazoles Gdi and Toimim, if the first longitude, the Eirach Rishon, is between 9 and 15 degrees, that is reason enough to make further calculations to know whether the moon will be sighted or not. In halacha Daled, he states, when the moon is found between the mazoles Sartan and Keshes, only if the first longitude is between 10 and 24 degrees is it necessary to make further calculations. Since the orientation of the moon in these latter mazoles is southerly, they are mazoles yordim, therefore a greater angular distance is necessary for the moon to be sighted. The next set of calculations are taught in halachas He through Tes. They begin with the following principle. All the calculations made previously were made from the center of the earth, but in actual fact, we are speaking about seeing the moon from the surface of the earth, from Yerushalayim. Here we see the moon's position from Yerushalayim. When the moon appears in the west, from Yerushalayim, it will appear even further westward, closer to the horizon. This longitudinal position is called Eirach Sheni. Its angular distance to the horizon will always be shorter than the Eirach Rishon. From Yerushalayim, the moon will also always appear more southerly than it actually is. The Roichav Sheni is always more southerly than the Roichav Rishon. That is to say, if the Roichav is northerly, the Roichav Sheni will be less northerly. If the Roichav is southerly, the Roichav Sheni will be even further southerly. These calculations are called Shinui Mare, sighting adjustments. The Rambam gives measures for the Shinui Mare to be made when the moon is found in each of the mazolos. The difference between the figures depends on the fact that each of the mazolos is seen from Yerushalayim at a different angle. Having established the position where the moon will be seen, the next step is to determine the angular distance between the moon and the horizon. In this way, we will know how much time there is to see the moon before it sets. Or to use different words, will the heavens become dark enough to see the crescent of the moon before it sets over the horizon? Halachas Yud and Yud Aleph. Here is the moon's location as it is seen from Yerushalayim. These are the points of the Oirach Sheni and the Roichav Sheni. These lines are projections of the longitude lines of the earth and can be seen as the longitude lines of the Galgal Hayomi, because the Galgal Hayomi revolves on the axis of the earth's poles. The Galgal Hayomi moves the moon towards the horizon. Therefore, according to these lines, we can calculate how far the moon is from the horizon. This is Oirach Shlishi, the third longitude position. It enables us to appreciate the Neliza, fluctuation mentioned by the Rambam in Halacha Yud. The angular position of Oirach Shlishi is shorter than Oirach Sheni. Here, the differences between Oirach Sheni and Oirach Shlishi are less because of the different angle. Here, there is no difference at all. If the Roichav is southerly, the Oirach Shlishi will be longer than the Oirach Sheni. In descending mazolis, in mazolis Yordim, the opposite will be true. A northerly Roichav will cause the Oirach Shlishi to be longer. When the moon does not have a Roichav, Oirach Sheni and Oirach Shlishi will be identical. As such, it is possible to understand halachas Yud and Yud Aleph. The differences that the Rambam calculates are as fractions of the Roichav, as determined by trigonometric functions. Halacha Yud Beis. After identifying the moon's position vis-a-vis the Galgal Hayomi, two more calculations are necessary in order to find how long before the moon disappears over the horizon. First, calculate the angular distance of a line which is parallel to the celestial equator, or the equator of the Galgal Hayomi, so to speak, drawn from the Oirach Shlishi to the horizon. This measurement will give you Oirach Revi, the fourth longitudinal calculation. The sum of its degrees will also give you the amount of time to the horizon, because the universe revolves according to the Galgal Hayomi, 1 degree every 4 minutes, 360 degrees in 24 hours. The last calculation. What is the actual Roichav, latitude position of the moon, before we reconciled it to this line? Because if it is northerly or southerly, it will actually set later or earlier than the point of Oirach Revi. By how much? We draw a line from the Roichav to our Galgal Hayomi line, which is parallel to the horizon line as seen from Yerushalayim. The meeting point is the indication of Keshes HaRe'iyah, the arc of sighting. The angular distance from this point till the horizon will indicate how long after the sun sets the moon will set. In other words, how dark will it get while the moon is still visible and we can possibly sight the new moon. From Halacha Tesvav and onward, the Rambam matches the Eirach Rishon with the Keshes Hari'iyah. If the Eirach Rishon is short, meaning the crescent of the moon is small, then a longer Keshes Hari'iyah is necessary so that it will be dark enough. If the Eirach Rishon is longer, meaning a larger crescent, then a shorter Keshes Hari'iyah is sufficient. The new moon could possibly be sighted even if the heavens are not very dark. To conclude with an anecdote, a group was formed in the city of Beitar on the outskirts of Yerushalayim, where visibility of the skies is optimal. The group tested the Rambam's calculations in Hilchos Kidush haChodesh, whether or not the moon could be sighted after the Moilad. Among them was a professor of astronomy who tried to prove that with modern science and tools of measurement, a better equation could be formulated. After time, it became clear that the Rambam's halachas are more accurate.